Let us discuss the programming that was uh, written here for a 4 by 1 mux that is written in the data flow modeling. The style of writing the programming data flow modeling. Here we can observe the keyword called as assign. So some value operation is performed on the left hand side by the operators and the value is assigned to the left hand side. Out is the output here and the program that is written for a 4 by 1 mux. Already we know that a 4 by 1 mux, nothing but it has two selector inputs, four actual inputs. So which input is appearing at the output that will be decided by selector, two selector inputs. So let us coming to the program. Module is the keyword, module. Module name, we can use any user defined name here. And the name that was used here is multiplexer 4 underscore 2 underscore 1 to identify that this particular program is written for 4 by 1 month. Within the parenthesis, we are representing the output side inputs. The outputs are out and the inputs are I0, I1, I2, I3 are the actual four inputs of 4 by 1 month with the two selector inputs as S0 and S1. We are declaring the output by the keyword called as output and the output is out. Terminate with semicolon. And the inputs, we are going to have actual inputs and the selector inputs. Actual inputs are the four inputs I0, I1, I2, I3 separated by the comma and terminated with the semicolon. And selector inputs are the two selector inputs S0 and S1. Using a single statement here, we are defining the whole logic of 4 by 1 month. The type of operator, here it is the ternary operator. So, before the question mark is the condition. If the condition is satisfied, then after the question mark, the statement will be executed. If the condition is not satisfied, then after colon, whatever may be the statement is there, that will be executed. That will be assigned. So here, we are going to have two selector inputs. So starting with S1 question mark. So before question mark is the condition. So S1, if S1 is true, nothing but S1 is going to take the value as logic 1. Then before this colon, this will be executed. This will be assigned. Okay. Then again, there is another condition called as S0. If S0 is true, means S0 is going to take the value as 1. Then after the question mark, whatever may be the thing is there, that will be assigned to out. Means what here? When S1 equals to 1 and S0 equals to 1, both are true, then I3 will be assigned to out. Else means what? When S1 equals to 1 and S0 is 0, then I2 will be assigned to out. Again, when S1 is 0 means this condition is not true. S1 is 0. If S1 is 0, then whatever may be the thing that is there, colon, after colon, it will be assigned. So this statement will be executed. When S1 equals to 1 and S0 equals to 1, then I3 will be assigned to out. And when S1 equals to 1 and S0 equals to 0, then I2 will be assigned to out. This is two set of inputs. 1, S1, S0. Both are 1, then I3 will be the output. When S1 equals to 1 and S0 equals to 0, I2 will be the output. I2 is connected to the output. Then, when S1 equals to 0, means after this colon, this comes into picture. Now, when S1 is not true, means false, means it is going to take the value as 0. When S1 equals to 0, then this condition comes into picture. Now, again there is a question mark here. Before the question mark is a condition. So, S0 may take the value as 0 or 1. If S0 equals to 1, then what happens? I1 will be assigned to out. If S0 equals to 0, then I0 will be assigned to out. Means S1 is 0 for both of the combinations, but S0, if it is 1, means the combination becomes 0, 1. Then I1 will be the output. If the combination is S1 is 0 and S0 is also equal to 0, then I0 will be assigned to out. In this way, this simple program, it is written for a 4x1 month. Started with the module and we are going to end the module. Let us see one more program written in the data flow modeling for a 4-bit ALU. ALU nothing but arithmetic and logical unit which performs the arithmetic operations as well as logical operations. So module name is ALU underscore DF1. Within the parenthesis, the output followed by inputs. Outputs are B is the output, C0 is the output, A is the input, B is input, F is the selector input, and CCI is also the input. So here, the inputs are represented by the keyword input CCI. A and B are the input which are declared as the vector here. 3 down to 0 means A is going to take the 4-bit value. B is also going to take the 4-bit value. Then the selector input. So how many operations, arithmetic and logical operations that are performed are addition operation, subtraction operation, XOR operation and complement operation. So two arithmetic operations and 2 logical operations are performed in this program. So to select which program, which operation is to be performed, we have to use the selector input. So F is the selector input. As we are performing 4 operations, 2 logical and 2 arithmetic, number of selector inputs required are 2. So F, the vector, F is represented in the form of a vector as 1 down to 0. Then the output, C0 is a scalar, so declared as Y declaration here. Outputs are represented in the form of Y. So D is the final output after performing the arithmetic and logical operations. D is the final output. If at all any carry occurs, that is nothing but C0. So output D is a 4-bit data, 3 down to 0, represented as vector. And another output C0, which is a scalar, just represented as output C0. Since it is written in the data flow modeling, we are going to use the keyword called as assign. We are going to use the flower braces indicating that a concatenation operation is performed between C0 and D. C0 is a scalar and D is a vector. So totally the bit length becomes D is of 4-bit and C0 is a single bit. Total length becomes 5. 4 plus 1, 5. Now, using the conditional operator here, before the question mark is the condition, if this condition is satisfied, whatever may be the statement after very near to the after the question mark will be executed. If not, after colon it goes to the statement after colon. It will take the statement after colon, after this colon. Now let us see. If F is of a 2-bit data, F equals to 2 bits of binary. If F is going to take the value as 0, 0, this double equals to indicates if F is equals to 2 bit of binary 0, 0, as it is the 2-bit data, it may take 0, 0, 0, 1, 1, 0, 1, 1 combination. If it is 0, 0, then very if this condition is satisfied, if f equals to 0, 0, if this condition is true, then addition operation is performed between the bits A and B, which are of 4 bit, to which a single scalar is added. After addition, the bit may take the value as 4 bit or 5 bit. So if it is 5 bit, then it is concatenated with C0. If it is 4 bit, it is limited to D only. Then if this condition is not satisfied, that means f is not equals to 0, 0, then what happens? Whatever may be the statement after colon will be assigned to the output. So after colon, you are going to have one more condition. What is that condition? If f is going to take the value of 0, 1, if this condition is true, means if it is 0, 0, then addition operation is performed. If not, it goes to the next condition, checking whether f equals to 2 bit of f is going to take the value 2 bit of 0, 1. If f equals to 0, 1, then next condition is satisfied. What is the question after question mark? What is the next statement? It is a minus b, means a subtraction operation is being performed between a and b. After subtraction, depending upon the bit we are going to take, we are going to get the digit as either 4 bit or 5 bit. Means we are going to get the borrow also. If at all any borrow occurs, that will be stored in C0. If not, the remain difference between A and B remains in D. So, if f equals to 2 bit of binary 1, 0, then subtraction operation is performed. If not, if this condition is also not satisfied, then after colon, whatever may be the thing that will be assigned. So after colon, when we are going to see, again, we are going to have one more condition where f is going to take the value as 2 bit of binary 1, 0. If this condition is true, before the question mark is the condition. If this condition is true, the next statement, very next statement will be assigned. Means what? If f equals to 2 bit of binary 1, 0, if this statement is true, then what happens is an XOR operation is being performed between A and B, and when we are going to perform any logical operation, the bits are not going to be added. So A is of 4 bit, B is also of 4 bit. After performing the XOR operation, the output is also 4 bit, but not 5 bit. So the fifth bit is Z means nothing but high impedance. 1 bit of binary Z is assigned to C0 and the XOR result is assigned to D. If F equals to 1, 0. Else means what? If this condition is not true, means F is checked with 0, 0, checked with 0, 1, then subtraction operation, checked with 1, 0. If it is satisfied, then it is XOR. If not, the rest combination is 1. If F is going to take the value as 1, 1, in that situation, A is going to be complemented, means you are applying the complement of A that is assigned to D and Z is assigned to C0. Like this, we are writing a program for a 4-bit ALU where A is of 4-bit data, B is also a 4-bit data, where you are performing the arithmetic operations of addition and subtraction between these two 4-bit data, and true logical operations, nothing but XOR and complement, not operation, are being performed on this two inputs A and B, which is of 4-bit data. The 4-bit ALU started with the module, we are going to end the module. So this particular program is written in the data flow module.